So reflection was over in the last class. Now we have to start with refraction. The refractive index has already been covered. Just revise it once. We'll start with the actual phenomena of refraction. So refraction is what? It's basically the change in path of light. What did I tell you when we had started with this? I hope I'm audible to all of you. Sana, Salman, Khalid.
Yes, teacher.
Okay. So, three phenomena we had observed that if light strikes on a surface, three phenomena are possible. One is that the light ray can exactly reflect back, and the whole process and the laws and the mirrors possible and the formula for it that we have seen. Second phenomena that was possible, that some amount of incident light can be absorbed by the surface also if it's an absorbing material. If it's a good absorber, then it can absorb more light. If the poor absorber, small portion of light will be absorbed. Third phenomena we have seen, if the light is able to pass from the surface obliquely, then we say that phenomena is known as refraction. So in the refraction, what happens? Let's say this is the interfering surface. This is the interfering surface. A normal will always be there, perpendicular to it. A straight line. I'm not able to draw it straightly. Just whenever you make it, please try to make it with the help of scale. Now what will happen? First, incident ray will arise. This is the incident ray. The angle of incidence, this is the normal. And instead of reflecting back, it will pass obliquely through this. And this becomes your refracted ray. This becomes your refracted ray. And now the angle between the refracted ray and the normal, this is known as angle of refraction. So what's refraction? Definition I have also already written. The phenomena of the change in the path of light as it passes obliquely from one transparent medium to another is called a refraction. It's called refraction of light. Now, why transparent medium? Because if your medium is not transparent, if it's an opaque medium, then the light will not be able to pass through it. So, object should be such that light is able to pass through it. Speed of light remains the same. The way we had laws of reflection, we had. What were the laws of reflection? Yes, Salman. Laws of reflection. We have studied it. Yes, Salman, Nasmi. Okay. Right now you cannot unmute yourself. Fine. Khalid, can you answer laws of reflection? Easy laws were there. I think you can repeat it.
Yes, teacher. Angle of incidence is equal to angle of R. And
reflection. And all the three lie in the same plane. Good, Khalid. Angle of incidence was equal to angle of reflection. But here we do not have this law that angle of incidence is equal to angle of refraction. Because if it is equal, then your ray will not be refracted. It will get reflected. That's why here this concept is not there. But we have the laws of reflection. So laws of reflection are there. Okay. See, the phenomena of refraction of light obeys two laws. First law is the very simple law. Incident refracted ray and the normal to the interface at the point of incidence lie in the same plane. Obviously, if it is an XY plane, every ray will be in XY plane only. No other normal reaction you'll obtain in ZX plane, and the refracted ray is in XY plane, and in YZ plane you're having the incident. No. Because basically the cause of refraction is the change in speed of light. Change in speed of light. That's why we see. Now, second law is your Snell's law. because we do not have that first law, but we have a relation between angle of incidence and angle of refraction. That we study. That is given by Lenz law. So Snell's law, sorry. So Snell's law simply says that if let's say this is your interface that we were referring to, this is angle of incidence and this is angle of refraction. So sine of I by sine of R, this is equal to a constant. The ratio is constant. Sine of what? Angle of incidence to the sine of angle of refraction is equal to a constant, and we have discussed this constant is simply your refractive index. So this is your second law, which is known as Snell's law. Sine of I by sine of R is a constant term that is equal to n. So even if there are two surfaces, let's say first surface is this, second surface is this. Light is traveling from the first surface to the second surface. So you can simply write sine I by sine R is equal to n2 by n1, or you can write it as n2 by n2. Refractive index will be the same exactly that you have studied. N2 by N1, N1 by N2, which is equal to N21, when it is equal to N12. All these things we have covered. So please revise refractive index, otherwise it will become very difficult to understand. Now there are two cases. Do you see how much oblique should I draw it? Should it be narrow? Should the angle of refraction be narrower? Or should the angle of refraction be wider? When I am drawing this, how much should be the angle? So that depends on the medium. You have two kinds of medium, rarer medium and denser medium. That also we have discussed, that when the optical density is more, you say it is a denser medium. And when the optical density is less, the object or your ray of light, that is your simply rarer. Now, if the ray of light is traveling from a rarer medium to a denser medium, if ray of light is traveling from a denser medium to a rarer medium, it bends towards them. See, this means what? This simply means you have this interface with you. Fine. A normal also you will project. A ray of light will be incident. This will be the incident ray of light, I. Now, let me just extend this. If there is no refraction, if no refraction occurs, if no bending of light occurs, then the actual path of the light should have been straight like this. Now, if when your ray of light travels from rarer to denser, means this medium is rarer, optical density is less, and this is your denser medium. So from rarer medium to the denser medium, light is traveling, it bends towards the normal. It bends towards the normal. So if I draw it like this will be away from the normal. So if I draw it like this makes it towards the normal, and here you get your angle of refraction. First tell me, is this point clear? How I have drawn this? If had it been away from the normal, I would have drawn it here. Since it is towards the normal, that's why here it is drawn. So let's say the refractive index of this side is N1, this is N2. Now, if you apply sine I by sine R is equal to N2 by N1, or you can do one more thing. Whichever is the refractive index, multiply it with that sign. For example, N1 into sine I is equal to N2 into sin r. See, both of these are same. If you cross multiply, you will get this only. But by this, you can forget whether it was n1 on the numerator, whether it was n2 on the numerator. So that can be confusing for you. So it's a better way if you do, whichever is the refractive index of that medium multiplied by sine. Refractive index of the medium multiplied by sine. By this, you can easily derive this as well as you'll be able to solve the numericals as well. From this only, numericals will be you will be able to solve all these. Fine. Now, if your medium 2 is denser, so refractive index of the denser medium is always greater. Remember this one. Because optical density is high, no, so refractive index will be more. It will take a very small amount of time to oblique or maintain the obliquity of the line. So N2 will be greater than N1. So if N2 is greater than N1, it means N2 by N1 is greater than 1. Fine. If N2 by N1 is greater than 1, then I can simply say sine I by sine R is also greater than 1, right? Because N2 by N1 is greater than 1. And N2 by N1 is equal to sine I by sine R. So from here, I can easily say that sine I by sine R is greater. So I can write sine I is greater than sine R. Did I just prove that I is greater than R? See, and you can even see it from the figure. Angle of incidence was greater than the angle of refraction. So if the question comes that prove angle of incidence is greater than angle of refraction, you just have to show that angle. This you just have to show. First, tell me any doubts till here. Sana, Salman, Khalid. Salman, you can at least text if you've understood, or you can just show a thumbs up if you've understood. Any doubts you have, let me know. Okay, clear to all of you. I have sent you all the marks. I hope you have received all your scores. So in the last test, EM waves test, Sana has done excellent. Sana, Sneha have done. And in the alternating current, Salman, Khalid has also done very good. Think I have shared the scores on WhatsApp. Till yesterday, all the papers were there. So if anybody has not received, just let me know. But in this batch, everybody has. Okay, so if you have understood, then note it down till here. Yes, Sana, for both the chapters. So it is out of 20. So Khalid, Salman, Sneha, Maimuna. Okay, your score is like this. Sneha has got 19 in this. Khalid has got 19.5. Salman 14.5. Maimuna 10. Sana 13. Samaira 11. Now see if the light travels from denser to rarer medium. Now your this medium is rarer and this is denser. See the changes that will come. This medium is now denser and this medium now is rarer. So whenever you have your medium that is, whenever the ray of light is traveling from denser to rarer, then ray of light moves away from the normal. So it means here as well, the ray of light will move away from the normal. So this is the normal, this is towards the normal, away from the normal will be here. So best way to draw these lines is that you draw the extended form of the incident ray. And wherever is the line of axis and the incident ray, you draw it above the away from the normal, and between the normal and the incident ray, you draw it towards the normal. So this is giving you towards away from the normal. Fine. From the normal, it is moving away. Now here you can easily say that n1 will now be greater than n2. So n1 will by n2, this will be greater than 1 because n1 is greater than n2 this time. It means we can say n2 by n1 will be less than 1. So you can say sine of I by sine of r is less than 1, sine of I is less than sine of r, and from here you can say angle of incidence is less than angle of refraction. Fine, from here you can even notice the fact that angle of refraction is great. Understood? And this will be the same, this formula that we have done. Sine of I by sine of r is equal to n2 by n1 is equal to v1 by v2. Fine. This is all about your refractions, light, incident ray of light, how it travels, what is the path that is covered. Refraction through compound plate we'll do, but before that, let's do a numerical on this. Do one thing, note it down till here. Once you have written it, then I'll note down the question and we'll discuss. Note down the second part. Make it as a second part and do it. See, the question says that a ray of light passes through a plane boundary separating two medium, like this, the way we have been drawing it, like this. Refractive indices are mentioned. Mu it has written, n also, as I told you earlier as well, n also you can write, mu also you can write. Fine, now ray of light is traveling from medium 1 to medium 2. So if we have to take, see, it's like, if I draw this is medium 1, this is medium 2, refractive index is mu1, refractive index is mu2. Incident ray has arise, angle of incidence is there. Ray has bended, this is angle of refraction. All right, so refractive index here is mu1, sine is I, mu2 is the refractive index of medium 2, sine r is there. So what did I tell you? Mu1 into sine I is equal to mu2 into sine r. By this you can easily write Lenz's law as well, and the formula of Lenz's law has also been Lenz's law, I'm saying, sorry, Snell's law. So mu1 into sine I is equal to mu2 into sine r. Understood? Second part you all will do, so pay attention in the first part. Now mu1 is given as 3 by 2. Sine I, angle of incidence, is also mentioned to us as 30 degree. Mu2 is given as half, 4 by 3. It is given 4 by 3, and sine r is unknown. So this sine r will simply be 3 by 2 into half into 4 by 3. No, 3 by 4. This will become, when it will go on the other side, it will become 3 by 4. So this becomes 9 by 16. So angle of refraction will become sine inverse 9 by 16. All of you note this down. Second part, I want answers from all three of you. If you have any doubts in this part, let me know. I'll repeat it. Any queries you have asked me, any part you have not understood from theoretical and numerical, let me know. But try the second part. It's just medium 2 is here, medium 1 is here. So whatever differences will come, let me. First, note down the question. I think you people must have not written the question. No, note down the question. See the solution of first part. Second part, you all will answer. Otherwise, I'll ask you all to unmute yourself and answer.
Ma'am, can you show the answer for first one?
Both the parts, Sana, or just the second part? Okay, just have a look at the question. Let me know. I'll scroll it down, and then all of you try the second part. Salman and Sana also try. Khalid has answered. I hope you've written this question, Sana. If not, just let me know. I'll scroll it up again. Good, both of you are correct. Salman and Khalid. Let's quickly discuss it. So yes, easy. I think you all must have understood this. Now see, now your medium 2 is this and medium 1 is this. So mu2, mu1. Incident ray will come, it will get refracted. This is I, this is R. This becomes mu2 into sin I, medium refractive index of the medium with the sign of angle whatever it presents. Mu1 into sin R. So mu2 is what? 4 by 3. It was 4 by 3. Sine 30-degree, angle is same exactly in this question. Nothing has changed. Angle is same. And mu1 was what? 3 by 2. Sine. Please correct me because whatever I've remembered, that's I'm writing. If I'm writing something incorrect, just let me know. So this becomes 4 by 3 into half into 2 by 3. This is equal to sine r. Okay, 2 will get cancelled, fine. Right, so answer is 4 by 9. R will be equal to sine inverse 4 by 9. Okay, note it down. Let's take a break of 10 minutes. It's 10 o'clock here, no? So 10:10, I'll start. Whatever time is there at your place, accordingly we'll continue. 10 minutes break, let's take. Yes. So note it down, those who have not written. I think most of you, all of you have written. After 10 minutes, I'll start with refraction through compound plate. Two very small topics are there through lateral shift and compound. Okay, take a break, class. All of you are here. Can we start now? I think 10 minutes break was enough to freshen ourselves for a complete 2-hour class. Should we start? Khalid, Salman, Sana,
Yes, teacher.
all are here? All good. So that was about Snell's law that we have completed. Refraction through a compound plate is left. Let's do the refraction through compound plate. This usually doesn't come in your exam. Means more, it can come. It's a part of your syllabus. It can come, but maximum time I haven't seen this part coming. Usual application of Snell's law is there, but this topic is rarely asked. But it can be asked. Now, compound plate means not a single plate is there. So this is N1, this is N2, this is N3, and this is N1. Means because this is the same medium air, so that's why an N1 back. N2 is this orange plate part, N3 is this. So two refractive indices are present now. So ray of light, let's say this is the normal. So ray of light will strike from here. This is the incident angle and incident ray. This is your incident ray. Fine. Now normal is there. Let's say this point is A. A point is there. Fine. Refraction will occur. Refraction has occurred and this is R. Fine. This here refraction has occurred. Now, as it strikes this surface, because now this is not empty, this is not air back, it means now again you have to drop a normal. And now the incident ray is now the refracted ray of the A point. At this B point, your refracted ray, your incident ray is your refracted ray only. Let's do one thing. Let's write this as R1. Now R1 angle. Let's write the angle as R1. This is R1. Fine. So this will also be R1, angle of incidence. Now angle of incidence here. This is what? This is the angle of refraction. And that refracted ray is now incident. So this refracted ray and the angle of incidence is now this angle. Got it? Simple. This angle, which was the angle of refraction for A point, this has now become the angle of incidence. Now again refraction will occur from here. You will get R2. Again it will strike the surface back. So you will have a normal here. And ultimately this ray of light, it will escape, and this we call as emergent ray and the emergent angle. This is emergent ray and this is angle of emergence. And here also the angle of incidence over here, this was R2. Did you understand? Several refractions are now occurring because A point is there, B point is there, and you have C point over here. So at 3 points you have a refraction occurring. Understood? That's why incident ray came, angle of incident eye. It got refracted, so R1. Now this became the angle of incidence R1 and it got refracted R2. Now R2 became the angle of incidence for point C. So R2 is an angle of incidence and this E is the angle of emergence. R2 and E are in a straight line. No, they are deviating. Don't go by my drawing because I have to draw freely on the screen. They are deviating. Refraction is occurring. So whenever, yes, good Sana that you have mentioned this point as well. Whenever you all are drawing, draw it oblique. show as if refraction has occurred, because yes, you're right, this is looking as if a straight line. All these lines are not in a straight line, every line has been lit. So if you'll draw properly with the help of scale, this will not happen. Okay, now if we apply Snell's law, now if you apply Snell's law over here, see, if you apply Snell's law over here, see if incident and emergent medium are same. In this medium is there, this medium is there, this medium is same, so obviously angle of incidence should be equal to angle of emergence. If incident and emerging medium is same, then angle of incidence should be equal to angle of emergence, because that is in the same medium. So let's see if they are equal or not, if there is some other physics behind it. See, if you apply Snell's law at point A, if you apply Snell's law, then sine of I by sine of R1 will be equal to what? N2 by N1. And if you apply Snell's law at point B, this will become equal to what? This will be sine of R1, because R1 is the angle of incidence, by sine of R2, that is equal to N3 by N2. Understood? Like this. And if you apply Snell's law at point C, then it will become further. See, now your angle of incidence is what? Your angle of incidence is sine R2. Sine R2 by sine R3 or R3. You don't have R3. We have taken it as emergent angle, no, angle of emergent. Let's take it as E only. This will be equal to N1 by N3. So if you multiply all these three, see, it will become what? Sine I by sine R1 multiplied by sine R1 by sine R2 multiplied by sine R2 by sine E. This is equal to what? N2 by N1 multiplied by N3 by N2 multiplied by N1 by N3. See, sine R1 got cancelled. Sine R2 got cancelled. N2, N2, N3, N3, N1, N1. What are we left with? Sine I is equal to sine E. Did we prove this? Angle of incidence is equal to angle of emergence. So this proof can come directly to you. This proof can be asked. All right. Note it down. Khalid, since your network was lost, so just note it down. If you are not able to understand by it, ask me whichever point you have not understood. In this case, only the incident and emerging medium is same. But for previous cases, we have used N1 and N2. See, incident ray, the medium no in which incident ray has struck in. This is exactly air. And the medium in which emergent ray has emerged. That is the same medium. We have inserted a compound plate in between. Rest of the portion apart from compound plate is air. In other cases, what happened? There was an interfacing medium. Means one medium was above where the incident ray used to enter, and the medium below where the emergent ray or refracted ray used to come out. So that's why we had used N1 and N2. In this case, incident ray and emergent ray are lying in air only, air or whatever is that medium. A compound plate with two refractive indexes, two different medium are inserted in between. So rest of the boundary becomes air. So lateral shift in glass slab. Concept is same, formula you have to remember, and in the questions, previous questions, you will find this. A glass slab will be present. Again, I'm taking this point as point A. Incident ray will come, angle of incidence. This is your incident ray. Fine, angle of incidence is there. It has striked it. This is point A. Now the ray of light will get refracted. Angle of incidence is there, angle of refraction. Refraction has occurred at this surface. So if this is R, now the new angle will become R. So this R is what? This is now the angle of incidence for this part, this surface. Let's say this is point B. Fine. Again, it will get refracted. Let's say it has refracted like this. See one thing, when it gets refracted again, no, it becomes parallel to incident ray. So it will be somewhat like this. And now let's extend incident rays. If incident ray was not refracted at the surface, then the path of incident ray would have been this straight line. Since it is now refracted, there is a gap. This gap that we get, this perpendicular distance that we obtain between the incident ray and this emergent ray, this is now the emergent ray. This gap, this perpendicular distance that we obtain between the incident ray and the emergent ray, this is known as lateral shift in glass slab. Fine. This is what is known as lateral shift in glass slab. Let's say this is air, and this is your glass slab, and the thickness of the slab is T. So thickness of the slab is T. So lateral shift is what? Lateral shift, it is the perpendicular distance between incident. Khalid, are you asking something? Incident and emergent ray. Incident ray, emergent ray. So perpendicular distance between both of these, in between the incident ray and the emergent ray. This is known as lateral shift. Now see this part, this is referred to as the lateral shift. Let's say this is L. If you drop a perpendicular, this perpendicular distance becomes L. Let's name this something. This is already B. Let's name this as N. So if you see this triangle A and B, this is complete triangle A and B. N, B, A. This angle here, this angle here, this A and B triangle, if you notice. So if you see sine of, see this angle is what? Incident rays here. Is incident rays coming A, N, B. If you take the sine of this angle, see, this complete angle was angle of incidence. See, I am drawing it again. This was your incident ray. If there was no deviation, then this would have been your incident angle. Vertically opposite angle, you all agree? Now see, now what has happened? Now a refracted ray exists here. And this angle is angle of refraction. So how much will be this part? Can anyone answer?
Incident ray minus refracted ray.
Incident ray minus refracted ray. Yes, right. So sine, now if I talk about, this is exactly your angle A. Understood what is your angle A? This angle that we are getting. This is incident ray minus refracted ray. It's fine. So sine of I minus R we will take. Sine of I minus R. Now if you just take normal, this is I minus R. So sine theta will be what? This is perpendicular base. So it will be perpendicular upon hypotenuse. So perpendicular is this, hypotenuse is this, base is this. So sine I minus R becomes Bn divided by AB. Fine. So Bn will be what? AB into sine I minus R. From here you can say Bn is equal to what? This is AB sine I minus R. Sine I minus R. If you take cos theta in this, so cos R, just take cos R simply. If you take cos R, see in this triangle, not this triangle, this one. If I extend this, because for cos theta we have to, let's say this point is some M point, AMB, in triangle AMB. Let me mention you the triangle. This was derived, this was written through the triangle ABN. And now this I am writing cos R from triangle AMB. So your cos R is equal to what? Cos R. Cos theta, cos R here. So this is perpendicular, this is the base, this is the hypotenuse. So it becomes base by hypotenuse. So it will be AM divided by AB. Fine. Perpendicular is not there, base and hypotenuse are there. So AM by AB. So cos R becomes equal to what? AM divided by AB. From here, if you see what is AM actually and what is AB, if you see. AM is this separation. See, this separation is AM, and that is exactly the thickness of the glass slab. Understood? That is exactly the thickness of the glass slab. So you can write AM as T. So AB becomes equal to T divided by cos R. Understood? And from here also we can have the value of AB from here. If you write down the value of AB from this, see, two triangles we had seen. Yes, this value, this equation 1, and now you have this equation 2. So your final this value of Bn will be equal to what? Just put AB, AB's value here. So Bn, which is the lateral shift, Bn will be equal to AB. AB is T by cos R sine I minus R. So this is the formula of lateral shift, because Bn was the lateral shift only. Bn, which is equal to lateral shift, is T sine I minus R, which is equal to T by cos R multiplied by sine I minus R. So final formula also you have to remember. Before you remember the final formula, you have to remember the derivation as well, because this derivation also comes, numericals also come. One numerical we'll see, but before that, just note it down.
Ma'am, I got disconnected. What was the final formula again?
Final formula is cos T by cos R sine into I minus R. If you use both the equations, no, from the second, you just put the value of AB from triangle AMB and get the value of the lateral shift, that is BN, from triangle AN. See, question says what? A ray of light is incident at an angle of 60 degrees. So angle of incidence is 60 degree on one face of the rectangular glass slab whose thickness is 0.1 meters. Refractive index is 1.5. Lateral shift produced you have to calculate. See, formula is what? L is equal to T by cos R sin I by minus sin R. See one thing, class. Here, no, angle of incident, ray of light is incident at an angle of 60 degree at one place, thickness is 0.1, refractive index is given. Fine. All right, class. Angle of refraction is not given to you. In the formula that we write here, T by cos R, incidence angle is required, but you require angle of refraction as well. So for angle of refraction, we can use Snell's law easily because your refractive index is provided. So according to Snell's law, if you use, and remember the statement of Snell's law as well. So if you remember Snell's law, then your sin I by sin R is equal to refractive index. Angle of incidence is given as 60 degree, thickness is given as 0.1 meter, refractive index is given as 1.5, and refractive angle we do not know, lateral shift we have to calculate. So from here, sin R will be equal to sine of sine 60 degree divided by 1.5. So this makes it root 3 by 2 into 1.5 or 3 only, which can be written as 1 by root 3. So this is sine R. This, if sine R is this, then R will be sine inverse 1 by root 3. Fine. Now this is your R is given now in the main formula. Main formula is what? Your lateral shift is equal to T by cos R. See, sin R, this value here, it is given in such a manner that you cannot solve. Otherwise, in your exam, such a value will be given that R will be a definite answer, like 30 degree, 45 degree, 20 degree, like this, you will get the answer. Here, because of the data that was given, this was not exactly a previous year question. It was similar to a previous year question, so that's why we are getting in terms of inverse trigonometry. So we'll use it as it is right now, but then don't worry about your exams calculation. There you will get easy questions. So sin I minus R. So that becomes T is 0.1 cos of sine inverse 1 by root 3 sine of what is the angle of incidence? 60 degree minus R is sine inverse 1 by root 3. This is angle of incidence, this is angle of refraction. Fine, you can solve this. Whatever meters you'll get, that will be your answer. Okay, note down this question. Text me done once you have written. I'll stop the class. Any doubts you have, any queries from any of the topics, just let me know. See, Sana, here you don't need to solve because obviously sine inverse 1 by root 3 there. It could be any other value also, a different value that could be solved using with the help of only log table. So do not worry about this question. Leave it like this only. In your exams or other questions that are available, they have such a value where you will get, for example, instead of sine r as 1 by root 3, had it been sine r is equal to 1 by 2, then we would have got sine r's value exactly as 30 degree. So 30 degree could be solved like this. So leave this question's value, just understand how to solve it. Okay, okay. Done, all of you? Khalid has done. What about, okay, Sana has also done. Salman also completed. Okay, fine, class. Thank you so much. We'll continue with the other things on Wednesday now. Okay, take care. Allah Hafiz.